Hello, this is the beginning of chapter 6. This is the last chapter in the class. And you've already done 6.1, which was a review of solving all the types of equations that we've done so far. This last chapter is all about polynomial equations. So this is video number 25. This is chapter 6, section 2. And this first one is about dividing polynomials with synthetic division. So first, the word synthetic. What does that mean? I know you guys who were in all of the auto programs and diesel know that that means it is fake, essentially. So this is a fake type of division. And we're doing this so that you don't have to do long division, which you guys can't do with numbers, so let alone doing them with polynomial functions. So thank me, because synthetic division is super simple compared to that. The process is a little bit long to write out, but it's actually pretty easy to do. So the first thing I want to do, just to review some words, is to actually review long division. And here is the problem that we're going to do with that. We're going to do divide 613 by 4. And so that would look like this, 613 divided by 4, or 613 divided by 4, right? They mean the same thing. Or 613 divided by 4. And so the top number goes underneath the little house. The 4 goes out in front. And do you remember what those things are called? What is the number out in front called? What is the number underneath the bar called? So the one out in front is your divisor. So that's also on the bottom of your fraction if it's written in fraction form, or it's written out behind if it's written in a division form. Okay, the one that's underneath the little house is the dividend, or it's your numerator, or it's the first number. So you're going to see these written any of those, well, the first two ways. We're not going to be doing this, right? But it's the same idea. So if we were to do that, I don't know if you remember how to actually do long division, and I'm not going to teach it here because we're not going to cover it in this section. But you divide the 4 into the 6, it goes in one time. You multiply those two, you bring it down, subtract, you bring down this number. Then 4 goes into 21 5 times. Then you subtract, bring down the 3, and it goes into there 3 times. 3 times 4 is 12. Bring that down. And this is your remainder, right? Or this could be written as 153 and 1/4, where you have the remainder, that's not all going to fit in here, over your divisor. And that's important because when we do our synthetic division, if you have a remainder, and you will, then you're going to write it over your divisor, which is now going to be a binomial factor like 2x minus 4 or something. So it's going to look a little weirder than that, but it's the same idea, remainder over divisor. Okay? So what we're going to do is take some kind of polynomial function like 3x squared minus 11x plus 7, and we are going to divide it by 3x plus 1. And so I'm going to teach you this method of synthetic division in order to do that. We'll talk about the purpose of it after you learn the process for it. Okay? So let's switch to another screen and go through the process. So we're going to divide 3x squared minus 11x plus 7 by 3x plus 1. Okay, so first recall that this binomial part is your divisor, and the polynomial part in the front is your dividend. And I forgot to mention that the answer to a division problem is a quotient. I would imagine that you know that. Okay, so here's how synthetic division is going to work. First thing you're going to do, and I'm going to write the steps down on the right-hand side, and then we'll go back and do the math on the left-hand side. So number 1, we're going to set the divisor equal to 0 and solve. Okay, once you do that, in this case, here, I'll do this right here. I would hope that you guys, after all of your setting factors equal to 0 and solving, I would hope that this is something you're going to be able to do without actually writing down. But for those of you that need to write it down, feel free to do that. Show that you're moving the 1, dividing by the 3, and x is going to be negative 1/3. What you're going to do with that is you're going to make a backwards L over on the left-hand side of the page where you're going to do your problem and put what x equals into it. So I'll do that over in black underneath the problem. So I'm going to make this backwards L and put the negative 1/3 into it. That's step 1. Step 2, you're going to line up and write all coefficients from the polynomial dividend to the right of the backwards box from step 1. And there's just a little note here that you need to make sure of. Be sure that there is a coefficient for every degree variable in the dividend. So for example, if you start with an x to the third, make sure there's an x to the third, x to the second, x, and then no x at all. In this one, we have a squared, I'm looking up at the original problem here. We have a squared, a single x, no x at all. So every degree is accounted for. So I'm going to list the coefficients, and those coefficients are the numbers in front of the variables. So I have a 3, a negative 11, and a 7, and just leave yourself a little bit of a spot in between each of those, just a little bit of a space. All right, number 3. I'll have to do some scrolling up and down here. But number 3, I want you to, you're going to hear me say this a lot, leave a line, draw a line, drop the first number. Leave a line, draw a line, drop the first number. Okay, leave a line, draw a line, drop the first number. And here's what I mean by that. I want you to leave a space underneath the line of coefficients you just made. So you're leaving a line, drawing a line, that's the green line I just made, and then drop the first coefficient down below the line. Okay, leave a line, that's the space, draw a line, drop the first number. All right, now what we're going to do, next step, make myself a little bit more space here. Step 4, going to multiply the number in the backwards L by the number you just dropped below the line. You're going to put the product on the line under the next coefficient. Then add down and repeat the process. And sometimes I started with something squared. We might start with something to the 7th power. So you might have 8 coefficients there, and you're going to have to do this 8 times. So this one we're only going to have to do a couple times, but the next one I think I have to the 5th power. So you'll get more practice. Okay, so we're going to multiply the number in the backwards box, which is negative 1/3, by the number below the line, which is 3. So if we multiply those two numbers, we're going to put the product, the answer to a multiplication problem, on the line under the next coefficient and add down. Okay, so here's the deal. We're taking the number in here and multiplying by the number under the line. When I multiply a negative 1/3 by a 3, I get a negative 1. So that's going to go underneath the next coefficient. And now I'm going to add down. Negative 11 plus negative 1 is negative 12. And now you're going to repeat the process. Negative 1/3 times this negative 12 is going to be a positive 4. And then you're going to add down. 7 plus 4 is 11. And you stop there. All right, so now we have a couple of statements. Statement number 5, I'll make over here. The number farthest to the right under the line is the remainder in your answer. And I want you to get in the habit of circling it. So we know that that guy's the remainder, okay? All right, now there's a process. You have to create what's called the depressed polynomial. And so you have to create the depressed polynomial. With the remaining values under the line that you created, not including the remainder. So I'm going to highlight those here in yellow so you know what I'm talking about. Let me grab a highlighter. So we're talking about any other numbers underneath the line, not including the remainder. So the 3 and the negative 12 will make up our depressed polynomial. However, there's something else you should know that we might as well deal with right off the bat. Oops, I need a pen, not a highlighter. So here's a little note. If those values contain a GCF, you should divide it out. So you're going to reduce those numbers. So in this case, I can reduce these both by 3, right? So the 3 is going to become a 1, and the 12 will become a negative 4 if we divide these both by 3, because that's the GCF. Okay, so here's how you're going to create this depressed polynomial. Remember that, I must switch to red just so it stands out. Originally, from the original problem, the 3 had an x squared on it, the negative 11 had an x, and the 7 didn't have an x at all. Well, we're dividing by something with an x on it. So if I divide an x squared by an x, I have an x left over. If I divide an x by an x, I don't have any x's. They cancel each other out. And this guy ends up being a remainder, so that's unimportant. So essentially what's happening is the first value under the line gets a degree 1 less than the degree that you started out with in the problem. This will be a little bit more evident when we do the next one, which I told you is going to be to the 5th power. So we're going to see how that's going to work. So the 1 gets an x and the 4 doesn't get a variable at all. So this just becomes x minus 4 with a remainder of 11 over 3x plus 1. So remember, I told you this is your remainder over the divisor. Okay, so this is actually the answer to this whole problem. The process isn't difficult. There's a lot of writing to make sure you guys have the steps down. So if you forget how to do it, you can go back and walk through all those steps. But let's go back and walk through another problem. This shouldn't take terribly long. I think I have 2 more to practice just to give you the idea. And then we'll go from there. Okay? So here's the next one. We have x to the 5th minus 16x to the 4th plus 60x to the 3rd plus 6x minus 39 divided by x minus 6. And these are written with parentheses around the polynomial, parentheses around the binomial. All right, well, your first step is to take your divisor and set it equal to 0 and put it in this backwards box over here. So you can do that in your head. If you take x minus 6 and set it equal to 0, you're going to get x equals 6. And that's going to go in here. That's not a step you need to actually show on your paper unless you feel that you need to. Okay? And then list out your coefficients, making sure you have a coefficient for every power. Now, the x to the 5th, the coefficient on that is an invisible 1, right? And we have, in terms of degrees, 5, 4, 3, 2. There's no squared power. So we're going to need to put a 0 where that missing degree is. So I'm going to go 1, negative 16, 60, 0, 6, and negative 39. So if you want to put a little note over here, you can say, be sure to put a coefficient of 0 in if there is a missing term. Okay, so that has to happen. And I'm going to tell you, it's one of the most common issues that people miss when they go through and do these problems. They don't always check for that. And then you're off by a term and you don't know why. So that's one of the first things I'm going to ask you is, did you look for all the terms? So then we're going to leave a blank line, draw a line, drop the first number under the line. All right, now I'm going to change colors. So I'm going to multiply the number in the backwards box, 6 times the number under the line. So 6 times 1, that's a 6. And then I'm going to add down. Negative 6, 16 plus 6 is negative 10. Multiply 6 times negative 10 is negative 60. I'm going to add these down. 60 minus 60 is 0. Anything times 0 is 0. Add down, you still get 0. I multiply again, I get 0. Add down, I get a 6. Multiply, I get 36. Add down, I get a negative 3. Okay, so now let's check out. Don't forget this last one. That's your remainder all the time. And I think the next one we do has no remainder. So you see what happens when we do that. Okay. And then we also have in here, I started out with x to the 5th, x to the 4th, x to the 3rd, x squared, x, no x at all. So we drop a power in our answers. So x to the 4th, x to the 3rd, x squared, x, no x at all. That becomes the constant. Also, if you don't have a negative sign on a number, then it's positive, right? So these would have pluses in front of them. And then in your answer, if it's a 0 as a coefficient, you just leave that off. So we have 1x to the 4th minus 10x cubed. This guy gets left out of the answer. This guy gets left out of the answer, plus 6. And then you're going to have minus 3 over x minus 6. And that's how this answer is going to look. We can't take a GCF out of the depressed polynomial, which, by the way, I just want to point out this thing here, right? That's the depressed polynomial without the remainder, okay? So that's the process. Not a lot of math there for all that writing that we did on the last page. All right, so let me give you the reason that we're doing this, and then we're going to practice one more of these. I need a different pen. So the moral of the story here, a lot of math that you have learned up until this point in your mathematical career, all the way from elementary school, has led up to solving polynomial equations. The moral of the story, if the binomial factor divides evenly into the polynomial, which means you have a remainder of 0, which we haven't seen happen yet. Then the binomial is a factor of the polynomial. And when set equal to 0, it becomes a solution to a polynomial equation. And so here's your goal with these. The goal is to perform synthetic division enough times to get the depressed polynomial to a quadratic that you can solve. Right? Because you have 3 separate ways to solve a quadratic. What are they? Let's name them. 3 ways to solve a quadratic. This is what this entire class has been leading up to. You guys being able to solve any type of equation, no matter what it's thrown at you. 3 ways to solve a quadratic. 1, 2, 3. Pause this video and see if you can write them down and fill them in, and then come back and see how you did. All right, here they are. 1, you can factor using X method. 2, you can use quadratic formula. Right? That's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Or you can use completing the square. The least common method, because it's got some complications to it, but it's a possibility. All right, so that's kind of the moral of the story. So you're trying to determine if a binomial is a factor of a polynomial to find out if it's going to help solve an equation. That's the deal. And if we were graphing these, you're welcome that we're not, it would also be an x-intercept on that graph. So that's another thing. All right, let's solve one more. Here's the last one. You're given 5k to the 4th plus 15k to the 3rd plus 20k squared plus 20k divided by k plus 2. All right, so take a look at this polynomial. That's a terrible 4 right there. So the first one is to the power of 4, 3, 2, 1. There is no constant on this, so make sure that you put a 0 in for a constant. First thing we're going to do, set this guy equal to 0 over here, the divisor. So that's going to be a negative 2 in there. Then we have 5, 15, 20, 20, and 0. Leave a line, draw a line, drop the first number. And then let's go through our process. We're going to multiply and get a negative 10, add down and get a 5, multiply and get a negative 10, add down and get a 10, multiply and get a negative 20, add down and get a 0, multiply and get a 0, add down and get a 0. The last one is your remainder. So because the remainder is 0, that means k plus 2 is a factor of the polynomial. Okay, which also means negative 2, when you set the factor equal to 0, negative 2 is an answer. So x equals negative 2 is an answer to, well, I guess it would be K, right? Because these were all Ks. Sorry, we'll make that a K. K equals -2 is an answer to the problem. So eventually where we're going with these is you're going to be given this polynomial function and it's going to say, solve it. You should have 4 answers because the degree is to the 4th. We know one of them. And then we could go from there. So here's the deal. We started out with a K to the 4th, K to the 3rd, K squared, and a K. This becomes K to the 3rd, K squared, K, and that's our constant. And we also have a GCF in here, right? So we can divide by 5, and this is going to give us a 1K to the 3rd plus 1K squared plus 2K, and that's it. Okay, so ultimately, you're not going to be asked to do this in this one, but if you were to set this equal to 0, you could factor a K out of here, and you'd have a K squared plus K plus 2. You can't factor this, but you could do quadratic formula on it, set this equal to 0, and use quadratic formula, which we're not going to do here, to find the other 2 answers. So we would know that K is 0, K is -2, and you get 2 answers from your quadratic formula to give you all 4 answers. And that's how you would go about solving one of these things. They get a little more complicated because your answers can be imaginary. We'll get to that later. In varsity, it's going to give you a problem like this and just say, is the binomial factor a factor of the polynomial? And it's a yes, no drop down box. Do not just answer those questions. When you submit your work to me, if there is not work for those problems, I will not give you full credit for them. I want to see you actually doing the synthetic division, getting a remainder or not, and then leaving an answer. So remember, if it has no remainder, it is a factor. And if it does have a remainder, then it is not a factor. So make sure that you are showing your work for numbers 15, 16, and 17 in varsity for full credit on your completion points. Alrighty. Well, that's it for this video. The next one, warning, it's probably going to be kind of long. And this one was a little long, but it'll be a little bit long. So go to the bathroom first, get yourself a cup of coffee or something to drink and eat before you sit down and tackle that guy. All right? Alrighty. Toodaloo.